give you some, will produce some geometric attribute for you. For example, the ArcGIS can compute the length of the line. So when you build up or to clean a map, after that, the ArcGIS will give you a column indicate the length of the link or the area of a polygon. Okay, so we call them geometric attribute. Right? And so, for example, here is a map. There are only there are 3 points, and after the construction of you construct the topology, and the system will probably can give you the ID of 1, 2, 3, 3 points, and their x coordinates and the y coordinates. These two geometric attributes. And for some application, you may build up your own table. There's 1, 2, 3, 3 points. You can see the tree type, what kind of tree, and the age of the tree. For the management unit, who will take care of the trees? Well, in a local government. So you can build up your own attribute table. I call it thematic tables, thematic attribute. So the system constructs this table automatically, and the user construct this table by yourself, and the system can link them together, to match them together. It becomes a relational database. Similarly, in the line layer, so there are 3 lines, 1, 2, 3 lines, and after the topology is constructed, the system will build up for these 3 lines, the start point, the ID of the start point, the end point, and the length is length. Okay, so the system, the GIS system can compute or produce this table for you automatically. And okay, you can make your own table for the pipeline, what kind of pipeline, the material, the depth, and the management department, so on and so forth. And the system can combine these 2 tables together. Okay. In the case of a polygon, so 1, 2, 3, 3 polygons. So for each polygon, there is an internal pseudo point inside. Actually, it could be randomly or find the central point of this polygon and use this pseudo point to represent this polygon. So here 1, 2, 3, 3 polygons, and probably some system will show the vertices of these polygons. So there's 1, 2, 3, 4 vertices. A list of the vertices, and then the length of the the side, edges, the length of the total edges, the total length of the edges, and the areas. So
perimeter.
Yeah, it's the area.
Perimeter and
Perimeter is not perimeter. The
total length of each size.
Just here, and here is the area in terms of square meters. Okay? So, and you can, for Department of Land Use or Land Management, they have the cadastral map and the registered areas and the ownership. Yeah. So the application department produced this semantic attribute. And,
All these will be linked.
and yes, in the relational database, the system will link them together because they share the same ID. Here's 1, 2, 3, here's 1, 2, 3. So the system, the relational database will combine them together or have build up a link automatically for them.
Here, if we are looking for some other information, the system may display the unwanted information, right?
What kind of?
If we are looking, we would like to know about the area and the ownership, but because of seeing the same ID,
Yeah.
it may display something about the.
So that's, you should be very careful. You don't you have to make sure the number 1 is this guy, number 1. you cannot duplicate 2, 1. Yeah, okay. Yeah, I will talk about it in the relational database. There are some regulation to make sure you link them correctly. Yeah. Because its ID means you must have a unique numbers, unique code for each one. And you must make sure this one is this one. 1 to the 1, 2 is compared to the 2. The same object. So here is the registered area. Actually, the registered area could be different from the area computed by the GIS. This poses a lot of problem. I don't know in your country.
Main problem is that, and somewhere even the boundary also doesn't match.
Yes.
Boundary goes something like that, and in the field it goes like
Yeah.
this. That's why I faced a lot of problems because
Yes.
I was working as a contraction, and the contraction was so difficult.
Okay, in recent years, some I believe in ArcGIS, probably they implement in this way. We call it integrated relational database. That means the graphic database can be stored in the relational database. Because in the previous, in relational database here, the relational database, these two databases are constructed separately in different data structure. But in this stage, they combine it together. They store the graphic database in the attribute database. They use the same data structure. But they use SDE, Spatial Data Engine, to read it. Yeah. So in ArcGIS, you can find SDE. That means, okay, they store the graphic data in the attribute database, in a relational format, but read it using SDE. So many OpenGIS use this way. But so far, commercial GIS implement their attribute or graphic database in this way so far. But theoretically, we have object-oriented database. Probably in the future. I don't know how many years we might have. Probably 5 years, 10 years. But theoretically, we can have an object-oriented database. Okay, the idea, I will explain it more detailed next time. But here I give you some best idea. Object-oriented relational database. In ArcGIS 9.x is use this idea, but actually they use the OO object-oriented in attribute database, not in graphic database. So the attribute database is object-oriented approach, but not in the graphics, not in map. Okay, so for the ArcGIS, the graphic database still use it's still in the layer based, not oriented, object oriented. Okay. Here, the object means geo object. Okay, any object, any geo object. Any object would be described by the ID identifiers. So each object, every object has its own identifier, unique identifier. And you must claim their data type. The data type for this object. It could be integer, it could be alphanumerical, something like that. And some functions or some method. Some system call it method. Actually, method is equal to the function. 就是 method 跟 function 只是名字不一样。So when we mention about the nominal, ordinal, interval, and the ratio variables, the variables is the data type. What kind of the variables? What kind of data type? And they associate particular functions. So you have to say what kind of functions can perform upon this object. Okay? So for a document, you can delete it, you can insert it, you can copy it, but you may append it, right? But probably you cannot do. You can add addition or subtraction. This abstract, you can compare two documents, but you cannot operate some arithmetic or take the rule, square root. It's meaningless. Okay, right? So you must define what kind of functions you can operate upon this object in what condition. Okay, and or in what constraints. Condition means in some condition, under some condition, you can do this function. For example, actually in the Word is an object-oriented approach program applications. So we must do some. So let me see. Okay, here, okay. At this moment, you cannot, this function is a cut, it's copy, right? But you can, at this point, you cannot do it. You cannot do this function because you must mark first. When you mark something, you can do it or do it. So it is condition. Under this condition, after marking some, yeah, and you can do copy or cast, or cut or paste. Actually, you must copy or cut, then you can do paste. Otherwise, you cannot do paste. That's condition. Okay. So it's some operation. That's the data, and it's the operation, and you can do some functions, some conditions. And the constraint means, well, you cannot do something. That means, for example, you cannot divide it some number by 0. Okay, if the system find you